All right, if you are deep in the books for the AWS Solutions Architect exam, you know storage is a huge topic. So today, we're going to lock in on something you absolutely have to know inside and out: Amazon Elastic Block Store, or EBS. Let's get right into it. Seriously, think about that for a second. Your EC2 instance, that's the engine, right? It's doing all the heavy lifting, all the computing. But its brain, the operating system, the applications, all that crucial data, it needs a place to live. And not just any place. It needs a home that's persistent, super reliable, and fast. That's exactly the problem EBS was built to solve. And honestly, the analogy on the screen is perfect. At its heart, it really is that simple. EBS gives you these block-level storage volumes that you just attach to your EC2 instances. You can pop a file system on there, run a database, whatever you do with a normal hard drive. The key, and this is so important, is that it's persistent. That means your data is safe and sound even if you stop or terminate your EC2 instance. So, to get you prepped for the exam, here's our game plan. We've kind of covered point 1 already, EBS as your trusty virtual hard drive. Next, we're going to dive into the real workhorse, the general purpose volumes, focusing on GP3. Then, we'll level up to the high-performance stuff with Provisioned IOPS, specifically IO2. After that, we'll look at the big data movers, the Throughput Optimized volumes. And to finish, we'll hit some of those key concepts that love to show up on the exam. Okay, first up, let's talk about the general purpose SSDs. As a solutions architect, this is your bread and butter, your go-to volume for a massive range of workloads. The big decision you'll have to make here, and what the exam loves to test, is the choice between the older GP2 and the much newer, much better GP3. So when do you reach for one of these? Well, pretty much any time you need a great balance between price and performance. If an exam question mentions system boot volumes, dev and test environments, or maybe a web server that needs low latency response times, ding, 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 your mind should immediately go to general purpose volumes. Now, this is where it gets really interesting, so pay attention. The shift from GP2 to GP3 was a total game changer. You see, with GP2, your performance was literally tied to the size of the disk. If you wanted more speed, you had to pay for more storage, even if you didn't need it. But GP3 blows that model up. It decouples performance from size. You get a solid baseline of 3,000 IOPS and 125 megabytes per second of throughput, no matter how small the volume is. This gives you way more flexibility and, cherry on top, it's about 20% cheaper for the storage itself. And this quote just nails it. This is the key takeaway for your exam. If a question puts you in a situation where you're choosing between GP2 and GP3 for any new workload, the answer is almost always GP3. It's more flexible, it has a better performance baseline, and it's more cost-effective. It's just the better choice. All right, so what happens when good enough isn't good enough? Let's move up to the next tier, Provisioned IOPS SSDs. When you see an exam question that uses words like mission critical or sustained guaranteed performance, this is where you need to be. These are for the applications that can't afford any hiccups. We are talking about the heavy hitters here. Your massive production databases, whether they're relational like SQL Server or NoSQL like Cassandra. It's any workload where you need that consistent, low-latency I/O day in and day out. If the requirement is for sustained performance you can count on, GP3 might not be enough, and you got to step up to IO1 or, even better, IO2. So why IO2 over IO1? Well, the biggest reason is reliability. I mean, look at this number. The IO2 volumes are designed for 5 nines of durability. Now, that might just sound like marketing fluff, but it means they are 100 times more durable than IO1 volumes. For systems where data loss is absolutely not an option, that's a massive, massive deal. And it's not just about durability, it's about raw horsepower. As you can see, IO2 completely blows IO1 out of the water. We're going from a max of 64,000 IOPS with IO1 to a mind-boggling 256,000 IOPS with IO2. That is a 4-fold increase. For your most demanding, IO-hungry applications, IO2 is the undisputed champion. Okay, let's switch gears completely. We've been talking about the sports cars of storage, the SSDs. Now let's talk about the heavy-duty semi-trucks, the HDD-based volumes. The Throughput Optimized ST1 and SC1 volumes are built for a totally different job. It's not about speed in terms of IOPS. It's all about moving huge amounts of data as cheaply as possible.
You should be thinking about big data frameworks like Hadoop and Spark, or maybe streaming data platforms like Kafka, massive data warehouses, or just processing huge log files. In all these cases, what matters is throughput, the total amount of data you can shove through the pipe per second, not the number of little operations.
But, and this is a huge but for the exam, there's a catch. These volumes have a very specific sweet spot. They perform best when your I/O operations are large and sequential. We're talking 1 megabyte block sizes ideally. If your application is doing a bunch of small random reads and writes, it's going to perform terribly on these drives. The exam will absolutely try to trick you with a scenario that sounds perfect for ST1, but then sneak in a requirement for high IOPS. Don't fall for it.
Okay, we've covered the different flavors of volumes. Now, let's dig into a few advanced concepts that are prime material for those trickier exam questions. Getting these details right is what can make all the difference. First up, multi-attach. This is a really cool feature. It lets you take a single EBS volume and attach it to multiple EC2 instances at the exact same time. Think of it like a shared network drive, but with the high performance of a local block device. The key thing to remember, and this is exam gold, is that this only works for provisioned IOPS volumes, so IO1 and IO2. Now, with great power comes a bunch of rules, and the exam loves to ask about these limitations. First, you have to be using Nitro-based instances. You can't use a multi-attach volume as a boot volume, which makes sense. And here's the big one. You cannot use a standard file system like ext4 or XFS. They aren't cluster-aware and you will corrupt your data. You have to use a special clustered file system. Oh, and also notice that IO fencing, which protects your data if things go wrong, is only supported on IO2. Another win for IO2. Finally, let's touch on encryption. As an architect, you basically have two ways to think about this for data at rest. With client-side encryption, you encrypt the data on your EC2 instance before it ever leaves for EBS. You manage the keys, and to AWS, it's just a bunch of random encrypted data. With server-side encryption, you send your plain text data over to EBS, and AWS handles the encryption for you, usually with keys from the AWS Key Management Service. The critical difference is where the encryption happens and who holds the keys. So, we've gone through the specs, the types, the features, the whole shebang. But remember, being a solutions architect isn't about memorizing tables. It's about listening to what a client needs. Cost-effective, highly durable, high throughput, and being able to translate those business requirements into the right technical solution. That's the real test. That's what the exam is trying to measure, and now you're that much more prepared to ace it.